Here's the rational zeros theorem. It says f is a polynomial, so I got to have a polynomial. Can't be anything other than a polynomial of degree 1 or higher, and has to be of this form. The leading coefficient isn't 0. The constant isn't 0. The important thing, the next thing is, says, if I'm going to use this theorem, each coefficient is an integer. And you're going to say, well, what are the integers? Well, the integers are dot, 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 -2, -1, 0, 1, 2, dot, dot, dot. It says they're whole numbers plus or minus. Then it says, if p divided by q in lowest terms is a rational zero of f. Now, here's what's important in this statement. Rational always is fractional. So they're nice numbers. It's not going to be like the square root of 2 over 3. When you're talking about a rational number is a fraction. The fractions that we know and don't love so well. 5/2, 3/4. If p divided by q in lowest terms, what lowest terms means, reduced form. Is a rational zero. Rational zero, when I'm talking about rational zeros, these guys are the x-intercepts, solutions, roots. That's where we take the polynomial f of x, set it equal to 0, and solve for x to find the zeros. And we're looking at this strange p divided by q thing. Then p must be a factor of a0, and q must be a factor of an. Now, to me, I've got to think about an is the leading coefficient. And a0 is the constant. Now, that still isn't good enough for me. It's just too hard. My little brain can't maintain that. However, if I think about a0 being the leading coefficient, he is in the front of the bus. He leads, he's in the front. If I look at a0 as being the constant, he's the caboose of my train. He's in the back of the bus. So now, if it says take p divided by q, p is the guy who is in the back, q is the guy that's in the front. Back divided by front, alphabetical order. You take the back divided by the front. Now, what are you actually going to take? You're going to take the factors of the back divided by the factors of the front. And when I think factors, the word that comes to mind that's much more useful is the idea of divisors. You take the divisors of the front divided by, or back divided by the divisors of the front, and then you reduce. Now what this does is, it will create a list of all possible rational zeros. Those are the only numbers that can be rational. That means those, if I have zeros that are not in that list, they're imaginary or they are irrational, radicals, square root of 2, 1 minus the square root of 5. Anything that's nice numbers, that also means that factors nicely would be in this list. And they mean all. They mean all. All means all.